All right, in this video, we're going to look at question number 4 on the worksheet that deals with the pH scale. So pH is a measure of how acidic or how basic a substance is. You can see in this chart that it ranges from a low end of 1 to a high end of 14. And right in the middle with a pH level of 7, we refer to this as a neutral substance. So pure water has a pH of 7, it's neutral. As you go lower on the scale, you get more acidic, so you see things like tomato juice, lemon juice, gastric acid. As you go higher on the scale, you get more basic, so things like baking soda, ammonia solution, bleach. Okay, and by the way, base is also referred to as alkaline. Okay, so to compute the pH, okay, we're going to compute this quantity right here. So we take the opposite of the log of this expression right here. This is a bracket with an H plus. And what is that thing? Well, this symbol here denotes the concentration of hydrogen ions for the substance in moles per liter. Okay, so if you have never taken chemistry, that probably sounds rather strange. And don't worry so much about the chemistry side of things. This is a math class, so we'll focus on the math in this question. But on the other hand, if you've taken chemistry, you may have seen pH, and so hopefully this will help deepen your understanding. Okay, so let's look at part A. It says, what's the pH of a solution for which the hydrogen ion concentration is 0.1 moles per liter? How about 0.01 moles per liter? How about 0.001 moles per liter? Then it says, what happens to pH as the hydrogen ion concentration decreases? All right, so here are the various concentration levels, and so we're going to compute this pH, this opposite of the log quantity for each one of these values of H plus. So let's go ahead and do that for the first one here. So our pH would be the opposite of the log of 0.1. Okay, so now notice 0.1, that's just a tenth, right? So just off to the side here, if I want to take the log of 1/10, keep in mind that this is a base 10 logarithm because you don't see that subscript base written. And so here we're saying, well, 10 raised to what power is going to come out to be 1/10? And that would be minus 1, right? I'm just going to take the reciprocal of 10 to get 1/10. So we're saying that the log of a tenth is -1, but then we're taking the opposite of that. So what is that all going to come out to be? The opposite of -1, and that would come out to be 1. So when the hydrogen ion concentration is a tenth, the pH level is 1. So we're going to be down here at the very, very acidic end of the scale. Okay, let's do the next one. So this is H plus equal to 100th. So for our pH, this would be the opposite of the log of 100th. Well, 10 to what power would be 1 over 100? Well, now I'm going to have to take a reciprocal, but I'm also going to have to square. So that's going to be -2, but I'm going to take the opposite of that. So that's going to give me 2. Okay, so I've gone from 10 to the negative first for a tenth here, then to 10 to the negative second, and notice what's happening to the pH level. It's going up by 1. Okay, all right, for the last one here, we have 1,000th. So this would be minus the log of 0.001. So to get 1,000th, I'm going to have to raise 10 to the minus third power, and then we're going to take the opposite of that. So that's going to come out to be 3. Okay, so then we can say this, as the hydrogen ion concentration, this H plus, goes down, what's going on with our pH? it's going up. Okay, so as we move to the right on the scale, the hydrogen ion concentration is decreasing. Okay. All right, how about B, lemon juice? This has an H plus level of 5.07 times 10 to the negative third. Our job is to find the pH level of lemon juice, which is roughly about right here, okay? Well, first notice that this 10 to the minus third, okay, that's really a thousandth, and so we're saying take 5.07 and multiply it by a thousandth, and what does that do? It's just going to move our decimal place 3 spots to the left. 1, 2, 3. Okay, so we're going to get 0.00507, so 0.00507. Okay, so then to find the pH level here, well, we can go ahead and say pH of lemon juice will be the opposite of the log of its H plus level. This is 0.00507. I'll go ahead and just use a calculator because I can't really do that one by hand. 0.0, here we go. So we want the opposite of the log, 0.00507, and I get about 2.295. So about 2.295 is our pH level for lemon juice. And you can see that's consistent with what we're seeing here. Of course, they're saying, it's around 2. Okay, cool. That's great. And then lastly, C, it says human blood has a pH level around 7.45. So notice here, this is just going to be to the right of water. It said, is this acidic or is it base? Well, since we're a little bit higher than water there, we're going to be basic. So I'll just say here, this is basic, but pretty darn close to neutral. And then it says, what's the hydrogen ion concentration? So this is just basically turning part B around. In B, we were given H+, we had to find the pH. In C, we know the pH. Now the question is, how do we figure out H+? Okay, so I can just go off of the fact that pH is equal to the opposite, the log of H+. Okay, and now since I know that the pH for human blood is 7.45, I'm going to put that in right here on the left side. So this would be minus log H+. Now go ahead and divide both sides by -1 just to get the log on its own. Continue over here. So we're looking at minus 7.45 is equal to the log of H+. And so now, given that this is a base 10 logarithm, I can now do what? Well, 10 to this number right here will equal H+. So here's what I can say. H plus is going to be 10 raised to the minus 7.45. And now let's go ahead and just go to the calculator. So we'll do 10 raised to the minus 7.45, and we get this number. It's about 3.548. So about 3.548, and then it was times 10 to the minus 8th here. Okay, so this would be saying move this decimal place to the to the left 8 spots. Okay, so very small number there, right? Okay, that's going to do it. That would be our hydrogen ion concentration. Okay, thanks so much.